Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on our system designing fundamental playlist, and the topic that we will be discussing today is the second part, and that is the network protocol. So in our last video on network protocol we have seen that what is an OSI model, and with the help of a very easy analogy we have tried to understand that what are the layers of the OSI model, and we have seen that how each and every layer is responsible for creating a communication between the client and the server. So as I was telling you in our last video, with respect to the system designing, the three layers are the most important layer for our system designing in our OSI model. That is, number one, the application layer, means the seventh layer. After that we have transport layer, and thereafter we have our important third layer, that is the network layer. So for designing any system, having the knowledge of these three layers is actually sufficient. So in this video we will go inside each and every layer, means all the three layers, and we'll try to see that what are the components or what are the protocols that are there in each layer, and why understanding all this protocol is actually important for designing any system. So initially I was thinking that I will start with our third layer, that is the network layer, where we will be discussing with the IPv4 and the IPv6. But honestly speaking, later I realized that it will be much more systematic way to understand the concept if we start in the reverse way. Means we will start with our application layer and then we will go towards our network layer, because the application layer deals with the things that we normally interact with. So understanding the things that we interact with will be much more easier for you to understand, and then we will go internally that how the things are actually working. So what we will do, we will start with our seventh layer, and that is the application layer. So the protocols by which we actually communicate between a client and the server are, number one, the HTTP, number two, the HTTPS, then the WebSocket, gRPC, DNS, SMTP, and all these things. So all these components of the protocol are actually the part of our application layer. So we will start our discussion with our first topic, and that is our HTTP protocol, which means that hypertext transfer protocol. But as usual, we will not go into the theoretical definition of what is an HTTP, what is an HTTPS, and all these things, and we will not go through all this detail. You can easily go through my website. Everything is hosted over there. You will get to know everything regarding all this protocol in detail, the theoretical aspect. But what we will see, we will try to understand here everything with the help of simple analogy, so that it will be very easy for you to recognize and to memorize all these things. So let's first understand that what is the HTTP and HTTPS and all these things with the help of a simple, very simple analogy. So let's take an example. We have two friends, friend 1 and the friend 2, and they want to communicate with each other with the help of a WhatsApp or a normal call. So what normally happens that whenever we call a friend, we first tell hello. The friend in response will also acknowledge with a hello, and thereafter what we normally say, we confirm that whether he can hear us properly or not. Similarly, in our system designing, or similarly whenever you are communicating with any server or client, the same thing actually happens between a client and the server. So for example, this friend 1 is nothing but your client, and this friend 2 is nothing but your server. And as I was discussing, before we communicate with the server, is before we request some data from the server, this series of steps also happen in networking. And whatever we have seen here, which we called it as a TCP protocol, which lies on the fourth layer of our OSI model. So here if you look carefully, TCP is nothing but the transmission control protocol. Means before you start any communication with a server or a client, this is one of the backbone of any communication. So the first a TCP connection gets established, means you discuss with your client and the server that whether it is possible to do a communication or not, and if everything goes well, a TCP connection gets established between the client and the server. So TCP is one of the protocol of communicating between the client and server. Now since you have understood that how a client and the server normally talks, or how they decide that whether it is a good time to talk or not, then what happens, there are different ways by which a server and a client can communicate. Now let's take an example. The friend 1 is simply sending some data or sending some information to friend 2, and that is a simple communication. Now once the friend 1 is about to tell some gossip, what the friend 1 will do, he will get a confirmation that whether anyone is beside or not, so that he can tell some secret message or some secret information about someone else. So before sending a secret message, what the friend 1 did, he have verified that whether the friend 2 is alone and there is no one who is overhearing them, then only what the friend 1 did, he have given the secret message. So on the first scenario, when the friend 1 was simply discussing something with the friend 2, means sending some data, at that time what it was doing, it have established a simple call that what we call in networking HTTP, means whenever you are sending some data from one server or one client to another client, then we simply open a connection, and with the help of the HTTP connection, we just send the request or some data from the client to the server. But beneath the scene, before establishing a communication via HTTP, what is there? We have the TCP, that is the backbone of this HTTP. Means until and unless this TCP connection is not established, means you are not sure that your friend 2 is hearing you or not, you cannot start an HTTP connection. I hope that is clear. Now what we do, before friend 1 have sent a secret message to friend 2, he have also asked one more thing, that whether friend 2 is alone or not. So there was a confirmation before sending some secret message. Similarly in networking, whenever we want to send some message which need to be securely delivered to the server, at that time what we do, we use the protocol called as a HTTPS protocol, which is nothing but a secure way of transferring data between the client to the server. So HTTP is a normal way of sending the data, but if you want that your data goes from the client to the server in a secure way, and there is no hacker or no person who can overhear you, and it should not be intercepted, at that time we start our discussion with the help of this HTTPS protocol. I hope this is clear that what is the difference between a HTTP and a HTTPS protocol. But there is one more important thing, that is, before we establish a HTTP request between client and the server, this acknowledgement or confirmation is done with the help of another protocol that is called as a TLS. So here also in networking, TLS is the first step before you establish an HTTPS connection. I hope this is clear that what is the difference and how an HTTP and a HTTPS connection gets established in the backend. So any connection you are opening, whether it is HTTP or HTTPS connection, the main backend is nothing but the TCP. And once a normal HTTP gets generated, what we need a confirmation that whether it is a secure way of sending the data or not. And that is why what we do, we rely on another protocol that is called as a TLS protocol. So here you can see it is known as the transport layer security. So it is nothing but a tunnel that gets created during the communication so that the data can be sent between the client and the server in a secure manner. I hope this is clear that what is the difference between the HTTP and the HTTPS. So now since you have understood that what is an HTTP, what is an HTTPS and what is a TLS, now let's understand another important thing, and that is the WebSocket. So what we normally do whenever we are discussing between the client and the server or between two friends, what we normally do, we initially start our conversation, means I tell hello, my friend tell hello, and in this way we start the conversation. But at some point it happens that the communication start in both ways, means I am telling something, my friend is telling something. So all these things are happening together. It is not that I complete everything and then only my friend will reply. It is not like that. In real life what happens, there can be overlap between the communication. So there is a bidirectional talk that can happen whenever we receive a call or whenever we are talking with someone. And to establish this bidirectional call, we have our next protocol that is nothing but as a WebSocket connection. So here if you look carefully, WebSocket connection is nothing but a persistent two-way channel, means here we are establishing a channel or establishing a pipeline where both the server and client can communicate with each other simultaneously. So in normally what happens is like For example, here we have a client and here we have a server. So generally what happens, it is the responsibility of the client to request some data from the server. So it is just a one-way communication. So for example, this is a Facebook client. So what the Facebook application or the client will do, to request photos of a particular friends or photo of the timeline, the Facebook client will start requesting the data from the server. That is the Facebook server. So here you can see this is a one-way communication, means every time the client will request some data from the server. Similarly, there can be one more approach. There are some data that got prepared in the backend, and there is some use case for which the server needs to tell the front end, that is the Facebook client, that some data got populated or some data got prepared in the backend, and the server want to notify the client that since the data got created in the backend, you can fetch it accordingly. So at that time, here if you look it clearly, the server is giving a notification to the client, means the server is pushing the data to the client, not the reverse. So this type of communication, we call it as a SSC communication, means a server side event, means the data has been prepared on the server and it is the responsibility of the server to send some data to the client, means send some notification to the client with some data. But here if you look carefully, both this way of communication is one directional, means here in the first case the client is requesting data from the server. Similarly, in the second case also, the server is pushing the data to the client. So both of these requests are one directional. But what if both the server and the client want to communicate together? So at that time only we establish a connection called as a WebSocket connection. Here if you look carefully, there is no arrow, means there is no single data flow. Both the client and the server can communicate between each other simultaneously. That is why it is called as a bidirectional persistent full duplex connection. I hope this is clear that what is the difference between these three type of communication. Now let's understand that how this WebSocket connection actually exists or how it actually gets created in the real life. So here if you look carefully, we have already understood that what is the difference between an HTTP and a HTTPS connection. So WebSocket connection is nothing new. It is the same way of how we establish a connection. The only thing is like before we open up a WebSocket connection, there is one more request that goes from the client to the server, and that is an upgrade request to convert any HTTP or HTTPS connection into a WebSocket connection. Means if you understand this correctly, a HTTP or a HTTPS connection is already established between the client and the server. Now if we want to do a bidirectional communication between the client and the server, what the client will tell in the header of the request, which we will see later how we send data in the headers and all these things, but as of now just understand that there is one more request that goes from the client to the server, that we want to convert this HTTP or HTTPS request into a WebSocket connection. And once that request gets generated or lands to the server, then only the normal connection get upgraded to a WebSocket connection. So behind the scene, WebSocket connection is nothing but an upgraded version of the HTTP connection. So here if you look carefully, I have mentioned it in my documentation, that is here the first an HTTP connection gets established, and once the HTTP gets established, then only we can request for an upgrade to a WebSocket connection. And once this upgrade is confirmed, then only we switch the protocol, means we convert the channel from HTTP into a WebSocket connection. And once a WebSocket connection gets established, means it is a permanent connection, means still the session is not expired or it is not disconnected manually by some client on the server. This connection will get persistent in the server, and both the server and client can communicate via that connection and can send data whenever they want. I hope this is clear that what is the architecture or steps behind establishing a WebSocket connection between a client or a server. So here if you look carefully from this TCP, there is one more thing, that is our WebSocket connection. And to establish this WebSocket connection, what we need either an existing HTTP or HTTPS connection, and thereafter we need another thing, and that is a header upgrade. Means internally we tell that this HTTP connection need to be upgraded into a WebSocket connection. And once all these things get fulfilled, then only a WebSocket connection gets established between a client and the server. I hope you are clear with that what is an HTTP connection, what is an HTTPS connection, and what is a WebSocket connection. Now there is one more important connection, that is nothing but a gRPC connection. So let's first understand that how this gRPC connection is different from all these three connections, that is the HTTP connection, HTTPS connection, and the WebSocket connection. So whenever a client is actually sending some data or requesting some data from the server, what normally happens, we do it with the help of this HTTP and HTTPS connection. And to establish the connection in the request, we send a lot of information in the header. So for example, from which client the request got generated, what is the type of request it is, what type of data it is requesting, what type of data it is sending. There are a lot of headers that is associated in our single HTTP or a HTTPS request. So here if you look carefully, this is our Amazon website, and here whenever we go into the network call, there are a lot of requests that are going beneath our Amazon website. And if we just take one of our HTTP requests, for example this one, here you will see that there are a lot of headers that we send into our server to make the server identify that these are the data which we need, or this is the request that got generated from a particular server. So there are a lot of headers you can see we are sending in a particular request. So here you can see we have the response header, we have the request header, we have some general header, and all these things. So whenever we are creating an HTTP connection, to establish a connection, there are a lot of things that we have to send, which makes the connection a bit heavy, and this actually slows down our network call. So for example, there is a river that is flowing at the speed of 10 km/h. Now here in this river, if we throw two objects, one is heavier than the other, it is quite understandable that the lighter object will reach from the starting point to the destination much quicker than the heavier one. Similarly, in networking, whenever you are establishing a HTTP connection, if your header size is huge, so the time duration it takes to send the data will also increase. So to solve this problem, what we have came up with another protocol that is nothing but the gRPC connection. And here in gRPC, the main added advantage is like the payload or the data that you are sending on the headers, or whatever the data you want to submit to the server is actually compressed. Means the size of the header is very negligible, so that the communication speed between the client and the server increases significantly. I hope this is clear that what is the difference between the HTTP, HTTPS, WebSocket and the gRPC connection. But there is one problem with this gRPC protocol, that is, here if you understand, here we are compressing the data. So there are some protocols by which we can simply send a gRPC connection, and since this is a compressed data, so the data which we transfer using the gRPC connection is not human readable. So here if you see in any of the requests whichever we are sending with the help of this HTTP call, means with the help of the REST call, all this data which we are sending in the payload is actually human readable. Means here you can see that we are sending the watch time, we are sending the post live, and all this data. So all these things are human readable. But in case of the gRPC, this is compressed version, so it is not possible for normal person and also not possible for the client to read this data. And that is why for normal communication between the client and the server, we cannot communicate with the help of the gRPC communication. Rather, what we do for any server to server communication, if two servers which is deployed internally within an ecosystem wants to communicate with each other, instead of communicating with the help of the REST call, we open up a gRPC. and there we do a lightweight transfer of the data between the two servers. I hope this is clear that how this gRPC is different from the HTTP connection, HTTPS connection, and all the REST connection that we normally does. Now, what is a REST communication? That we will also discuss very soon. But just remember one thing, that whenever we are requesting data from the client to the server, normally now in these days we do it with the help of the REST standard. Now here, if you look carefully in the documentation, here you will see that how this REST standard is different from this gRPC standard. Here you can see that this way of communicating with the help of this gRPC is actually 5 to 10x faster than our normal REST communication, by which we normally communicate between the client and the server. But the only downside is like the client cannot normally understand gRPC way of communication. I hope this is clear that how all these things are actually differ from each other. So right now we have already covered the first layer, that is the HTTP, HTTPS, WebSocket, as well as the gRPC. Now let's move to our next thing, and that is the layer 4 of the transport layer, where we have already covered one thing, that is the TCP connection. So here if you see, whenever we are actually creating any of the connection, or whenever you are opening any of the connection internally, we are using this TCP connection to establish all these things. So that is why TCP is nothing but the backbone of all the connection that we have discussed right now. And that is why here if you see, level 7 is the application layer, where we have all this way of communication, and internally we have the transport layer. Means for the application layer, this is actually, this transport layer is the backbone. So if you just take a very layman's example, so for example, you are creating a software on Windows. So the software that you create is nothing but the application layer and the architecture on top of which you have developed the software. For example, the .NET framework, that is nothing but your transport layer. So this is a simple example of how to understand that what is the difference between the transport layer and the application layer. Now let's see what are the other different type of protocols that exist in this transport layer. So we have already discussed this transmission control protocol, or the TCP connection. Now here there is one more way of communication, that is the UDP connection. So here if you look carefully in all the protocols that we have discussed, here all the way of communication is quite synchronized. Means user 1 is sending some data to user 2, similarly user 2 is sending some data to user 1. So there is some synchronization in which the data is getting transferred from one client to another. But for example, you are doing a video call with one of your friends. Now whenever you are doing a video call, what you are seeing on the front end, that is the live video of your friend. So at that time, if you see that, or if you look carefully, sometimes there is a glitch between the video if your network is slow. Means there is a small lag over there while the video is getting rendered in the front end. That is because whenever we do a video call, normally we take the advantage of the second protocol, that is nothing but the UDP protocol. UDP protocol, where there is no confirmation after sending the data. Means it is a one directional way of sending the data without any confirmation that whether you have received the data or not. So in our earlier discussion, means whenever we have established all this connection with the help of the TCP connection, at that time whenever you are sending the data to someone, at that time there is a response that comes back from the client or from the server, that whether the data actually reached the server or not. So in all the type of communication that follows the TCP, there is a response that we get from the servers. So here if you look carefully in the all the requests that the Amazon front end is sending to the backend, here if you see, there is a small field called as a status code, which have a value as 200 OK. Means this request have been received by the backend of the Amazon, and this is the response of that only. So in any of the TCP connection, there will be a response code for each and every request that a client is sending to the server. But in case of the UDP connection, there is no response, or there is no acknowledgement from the viewer's end or from the server. It is simply a one directional communication without knowing that whether the server have received the data. So that is the only difference between the TCP and the UDP. And since there is no confirmation that we are waiting from the server. So obviously the time to send the next call is also quite nominal. That is why the next protocol, that is the UDP way of sending the data, is actually very faster than that of the TCP way of communication. And that is why during the live streaming of the data, means you are watching a live match or you are doing a live video chat, at that time, to increase the speed of communication, we use this UDP way of communication. I hope this is clear that on a high level that what is an UDP and how they differ from each other. So here if you go through this documentation, it will be much more clear that how theoretically it actually send and receive the data. So here in case of the UDP, it is like fire and forget, means you just send and you do not care that whether the server have received the data or not. So here if I just play this, you will get to know that the data is simply going to the backend and there is no confirmation that is coming from the receiver. But in case of the TCP connection, here if you look carefully, there is a handshake that actually happens. Means, as I was telling you, before you start a conversation, there is an acknowledgement we receive from the server. So if I just play the video, so here you can see there's a sync that goes, then there is a confirmation that goes, then another acknowledgement goes, and thereafter data is getting delivered to the server. And once the data is also getting delivered to the server, there is also an acknowledgement that is coming. And that is why this TCP way of communicating is a bit slower than that of UDP way of sending the data. And on top of this UDP way of communication, there is another important feature that got recently built, and that is nothing but QUIC. So QUIC internally uses UDP way of communicating between the client and the server. So here you can see QUIC is a modern transfer protocol which is built on top of this UDP, which takes the benefit of the TCP, means the reliability and the acknowledgement ordering, everything is maintained. Plus we have the added benefit of this encryption and multiplexing. So these are some of the networking terms. So how this QUIC is actually giving the advantage? So here if you understand, in TCP 3 or 2 round trip communication that is happening, means you are sending hi, the server is sending hi, and then another acknowledgement is coming to establish this connection. So this actually creates an overhead or latency before we start the real communication. And to get rid of this one, we came up with a new technology which is called as a QUIC. So as the name suggests, it is the quickest way of doing a communication between the client and the server, and there is no extra or added step that is needed to establish this authentication or to establish this TCP connection. I hope this is clear that how this QUIC is giving you the added advantage on top of this TCP and the TLS connection, which is nothing but your HTTPS connection. So here you will get a complete thorough difference between all these things. So feel free to go through all these things whenever you get time. Also, I have given the complete difference between the TCP and UDP. So all these things are actually needed if your interviewer asks you the question. But to design any framework or design any system, all these things in detail is not necessary, but the knowledge of when to apply which protocol is actually very much important. And whenever you are explaining your design to your interviewer, you should be ready with all this reasoning that will back your decision. I hope right now you are clear with what is the TCP connection, what is the UDP connection, what is the QUIC connection, and how these things are internally different from each other, and on what use case you should actually use one of them. Now comes to our last layer, and that is our network layer, which deals about the IP address of the machine. So as we have discussed on the DNS video, that is to identify a server on the internet, we need an address, and that address in terms of networking is nothing but the IP address. And as we have discussed, IP address are of two types. Number one is the IPv4 and number two is the IPv6. So IPv6 is nothing but the modern way or the enhanced way of this IPv4. And here if you look carefully, here also I have given a thorough explanation of how the things are there on the IPv4, how the headers and the packet gets delivered in case of the IPv4. So whenever you are actually sending some data from the client to the server or between the server to server, you actually send the data in the form of the packet. And to send the data correctly between the client to the server, on each and every packet we mention both the IP, means the source IP, means the who is sending the data, and then we have the destination ID, means on which server we want to send the data. So each and every data you want to transfer is nothing but in the form of the packet, and if you are following the IPv4 protocol, this is how a packet should be designed to send it successfully. Now the main thing is like how this IPv4 is different from the IPv6. So as I have discussed already in my DNS video, that is an IPv4 have 4 octet, means it have 4 number which is separated by 3 dots, and the range of this octet lies between 0 to 255. I hope that is clear. And obviously, since a computer or a network does not understand a decimal system or a decimal number, so obviously we have to convert this number into a binary form so that the machine can actually understand that what is the binary value of this 192, and thus it decode that to which IP address it have to send the data. And as you know, the binary digit can be 0 or 1, means the total number of combination or the total number of IP address that can be generated with this IPv4 is nothing but 4.3 billion. So with the help of this IPv4, we can uniquely identify 4.3 billion machine across the globe. But recently, since the number of IoT devices that are coming up into the market is increasing day by day, so we have already exhausted with this total number, that is the top limit of 4.3 billion mapping at the end of 2011. So we have came up with our next solution, that is nothing but the IPv6, where a particular IPv6 model can be uniquely identified by 8 octet, and this 8 octet can generate a total number of 3.4 into 10 to the power 38 unique address across the globe, which is a huge amount of number, and there is no chance that this value will get exhausted. And that is why most of the modern technologies or modern devices that are coming is built on top of this IPv6 protocol. I hope this is clear that, and here also I have given you a thorough understanding on a very high level that what is an IPv6, IPv4, and what is the difference between the IPv6 and IPv4 protocol. I hope you are completely clear with this entire networking protocol that we have discussed so far. Means in our last video we have discussed about the OSI model, how each and every layer helps in sending the data, and here in this video we have seen in detail that how do we communicate between the client and the server with the help of these protocols, that is the HTTP, HTTPS, WebSocket, and all these things. And we will see in detail that with the help of this all concept, how we actually will send the data between the client and the server. Now comes the main thing, that is what we know. We know everything, that is how a communication should get established between a client and the server. Now let's take an example that here we have a client, and whatever the request of the data to the server, for example, that takes 10 milliseconds to process for the server. So each and every request that we are sending to the server is taking 10 milliseconds. Now let's take an example. There are a lot of clients that are there over here. So as you know, Facebook can be used by millions and millions of users simultaneously. And let's take an example. Each and every client across the globe is requesting data from this machine, that is nothing but the server. And this machine, for processing each and every request, takes 10 seconds. Now you can easily understand that since this is a server, and let's take an example that this server works on a single threaded system, means for processing the first request it will take 10 seconds. For processing the second request it will take another 10 seconds. So for example, if we get 1000 requests from the client, so the time at which the last request will get resolved is nothing after this amount of millisecond. I hope that is clear. One request is taking 10 milliseconds. So obviously the 1000th request will take the total time of this second. So you can easily understand that if a particular user is requesting for a data to the server, means to the Facebook server, and if the data is coming to me after this amount of second, that is actually a huge delay. Means I click on a button and after a minute or so the refresh on the screen is happening. So that is a very bad experience. So somehow we have to optimize it by making sure that this server compute this request or process this request in the nominal time, so that there is a very less delay on the client side of the system. And the way we achieve this goal is with the help of the scaling mechanism. Now what is the scaling mechanism all about? We will see in our next video, where we will see in detail that what is this problem statement I am talking about, or how the scaling actually works, what are the different type of scaling we have in the industry, and how it will be helpful to serve the data with the nominal latency. So see you in our next video, where we will be talking about the scaling mechanism and the problem that we face with this type of architecture. So see you on our next video. But before that, if you have liked this video and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon, so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video. Thank you.